Hello everyone, welcome to this physics tutorial. All right, let me read the question on the board and let's see what our task in the question is all about. Okay, then we can navigate from there. A motorbike and a car are waiting side by side at traffic lights. When the light turns to green, the motorbike accelerates at 2.5 meters per second squared. So which means the acceleration of the motorbike is 2.5 meters per second squared up to a top speed of 20 meters per second. Then the car accelerates. So now we have two different cases here. We have for the first one is motorbike. Now we have the car accelerates at 1/3 meters per second squared up to a top speed of 30 meters per second. Both then continue to move at a constant speed. Okay, now this is what we're going to do maybe when we are done calculating, calculating after what time will the motorbike and the car again be side by side, and also B, what is the greatest distance that the motorbike is in front of the car. So then we can now draw the graphs of velocity time graph for each vehicle using the same axis. Okay, then sketch the distance time graph, because T stands for distance, T stands for time, then S stands for distance. All right, so here is how to solve this question. Now, the first thing is, like I said, there are two cases here. Okay, let's have our solution. The first one is we have a motorbike. So for the motorbike, we have acceleration of motorbike. Acceleration of motorbike, that will be designated with AM, and the value of AM is 2.5, that is 2.5 meters per second squared, or 2.5 meters per second squared, up to a top speed. Okay, so we have the top speed of motorbike. Okay, up to a top speed of 20 meters per second. So top speed, let's designate that with V subscript n. Okay, and that will be 20 meters per second. Okay, so now, then also, so this is for motorbike. This is for motorbike. All right, then for the car, these are the informations, okay, from the question when it comes to the car. So now the car accelerates at 1/3 meters per second squared. So acceleration of car, which is AC, that is 1/3 meters per second squared. Okay, then we also have the now up to a top speed of 30 meters per second. So top speed of 30 meters per second. Top speed is just like when we draw the velocity time graph. We know that it will be a straight line drawn or passing through the origin. Okay, so when the motorbike, travels from, let me say, it goes from the origin to the top speed. So that means we need to first calculate the time it takes the motorbike and the car, to reach the top speed. For the motorbike, the top speed is 20 meters per second. Okay, and also we also need to calculate the distance during acceleration of 2.5 meters per second squared. That is in the case of motorbike. And then we do the same thing in the case of the car. So in this case, so the top speed of car, okay, that is equals to 30 meters per second. All right, so now we want to calculate after what time, that is the time after the start, will the motorbike and the car, be side by side. So after what time? When you say after what time, okay, will the motorbike and car be side by side? Okay, so that means we need to calculate time, okay, it takes the motorbike to reach its top speed of 20 meters per second, and also the time it takes the car to reach its top speed of 30 meters per second. So we have TC, okay, so where TN, okay, time to reach, this is time to reach 20 meters per second, time to reach 20 meters per second. Okay, then TC represents time to reach 30 meters per second. So to calculate this time, we know from V equals to U plus AT. So that means we know that if I put M, subscript N, so this is the acceleration of the motorbike. So we want to calculate the time of the motorbike. So the initial velocity of the motorbike will be 0. So the formula for T in this case will be velocity of the motorbike divided by acceleration of the motorbike. So the velocity of the motorbike, which is what we have here, that will be 20. Okay, we have 20 divided by, then the acceleration of the motorbike, which is 2.5. So this is 2.5. Then this is going to be, this will be 25 over 10. That's 200 divided by 25. Okay, this will be 8 seconds. So which means our Tm equals to 8 seconds, which is the time it takes the motorbike to reach its top speed. Then also we have Tc. To calculate Tc, I'm going to use the same formula. Tc will be velocity of the car, okay, divided by acceleration, so that Tc can be equals to, now we have Vc, this is Vc, this is our Vc, okay, Vc equals to 30 meters per second. Then the acceleration, that is 1 over 3, which is 1 over 1 over 3, and that's 4 over 3. So this would be 4 divided by 3. Okay, so when we flip the fraction, this would be Tc equals to 3 times 30, that will be 90, then 90 divided by 4. So that Tc will be, this is 9 divided by 2, that will be 9 divided by 4, that will be 2. We have a remainder of 1. Then 10, that will be 2. We have a remainder of 2. This will be 5. Okay. So the time it takes the car to reach its top speed will be 22.5 seconds. All right. So now, like I said, we are also going to calculate the distance during acceleration of 2.5 meters per second squared for the motorbike, and also distance during acceleration of 4 over 3 meters per second squared for the car. So which means that will be Sm, that is distance during 2.5 meters per second squared. Then we also have Sc, which will be distance during 4 over 3, okay, meters per second squared. That's it. All right. So now, to calculate this distance, we can then have, already we know that um equals to 0. So I'm going to make use of 1/2 of am multiplied by tm squared. Okay, so that this will be 1/2 of the acceleration is 2.5. So we multiply this by 2.5, then multiply by, then we calculated tm to be 8. So this will be 8 squared. Yeah, that will be 8 squared. So s subscript n, that will be, this is same thing as 1 over 2 multiplied by 25 over 10 multiplied by 64. So that this will be 32 when divided by 2. 64 divided by, that's 32. So 25 times 32. 25 times 32. This is 5. Okay, this is 15. That will be 7, 0, 0. That's 800. So we have, in this case, we're going to have 800 divided by 10, so that the distance will be 80 meters. The distance during acceleration of 2.5 meters per second squared. Okay, so now it's for us to calculate SC. So I'm going to use the same formula. Now it will be in terms of the car. So it will be 1/2 of the acceleration of the car multiplied by the time it takes the car to reach its top speed, raised to the power of 2. Okay, so this will be 1/2 of the acceleration of the car is this guy. So that will be multiplied by 4/3 multiplied by TC, which is 2.5 raised to the power of 2. Okay, and this will be 2/3. So the distance traveled during this acceleration will be 2/3 multiplied by, now I can use calculator. Okay, so we have 2.5 raised to the power of 2. That will be 506.25. So this is 506.25. Okay, 506.25. So 506.25 multiplied by 2. That will be 1012.5. This will be 1012.5. Then divide by 3. Divided by 3. 1012.5. 1012.5 divided by 3. That will be 337.5. So that SC will be 337.5 meters. This is the distance during the acceleration of the car. Nice. Now, because the question reads, after what time will the motorbike and the car again be side by side? That means when the time is greater than, when it is greater, after what time? That means the time after the start, when both the motorbike and the car, okay, are side by side. That will be the time. The time will be greater than, 22.5. Yeah, it will be greater than 22.5. So, okay. So now to calculate, let's make T represent time. Okay. When motorbike and car, okay, are side by side. Okay. So that means in this case, it means that the value of T will be greater than 2.5 seconds. Yes, it will be greater than 2.5 seconds. All right, so that means that we can now have, I'm going to what? I'm going to model an equation for the distance traveled by the motorbike, and that of the car. And that will be the distance in time T will be equals to the initial distance. The initial distance is 80, then plus the velocity of the motorbike, that is 20. Okay, we have 20 into T minus then the time. Okay, the time it takes the motor car to reach its top speed, that will be 8. Okay, yeah. So that means that of C will now be this SC, that will be 337.5 plus its velocity, which is 30, then T minus 2.5. So when this is equals to this, okay, then we should be able to calculate T. Yeah, because like I said, it will be greater than 2.5. So we have 80 plus 20 into T minus 8 equals to 337.5 plus 30 into T minus 2.5. So that this will be 80 plus 20T negative 160 equals to 337.5 plus 30T, then minus, so what is 22.5 22.5 multiplied by 30. That will be 675. So this will be minus 675. Okay, so let me combine like terms. So I'm going to make this one come here. So this will be 80 plus 675 minus 160. Then I'm also going to make this one come here. This will be minus 337.5. Then this will go to the other side. That will be 30t minus 20t. Okay, so if we add this together, okay, so let's check again. Yeah, so in this case, okay, yeah, so that means that we now have, this will be 5, then 15, then this is 755 because 0 plus 5 is 5, 7 plus 8, 15. Then, okay, then minus, this will be 337.5, 337.5, okay, when added to 160, that'll be 497.5, 497.5 equals to 10t. Okay, so when we subtract 497.5 from 755, that will be 10t will be equals to 257, okay, 0.5, 257.5. So if we divide both sides by 10, okay, so which means the time that both the motorbike and the car, okay, will be side by side again is, yes, this is again, that will be 25.75 seconds. And we just calculated this guy. All right, so the next question, what is the greatest distance that the motorbike is in front of the car? So in this case, when they say the greatest distance that the motorbike is in front of the car, so that means, okay, okay, let's do it this way. So let's do this way. Let me clean this part of the board. Okay, so B, we want to calculate the greatest distance. I think this should be, the greatest distance should be when we have to consider the interval between, the time between 8 seconds and 2.5 seconds. Okay, because if you consider the case 1, when t is less than 8, so definitely t will be equals to 0. Then case number 2, that will be when we have 8 seconds less than t, then less than 2.5 seconds. So in this case, this is the case where we have the velocity of the motorbike, which is 20 meters per second. Okay, and then the velocity of the car will now be acceleration of the car multiplied by t. So that will be, we then have the velocity of the motorbike to be equals to this. So the acceleration is 4/3, then multiply by time t. Yes. So if I divide both sides by 4, this will be 5. So I'm going to have 5 times 3. So that means t will be equals to 3 times. So we need to first calculate the time between 8 and 2.5. Okay. Yes, that's exactly what I'm doing here. Between these two time interval. So this will be 15 seconds. Okay, yeah, that's 15 seconds. So now we can calculate the distance, okay, the distance traveled by the motor car at 15 seconds and that traveled by the car at 15 seconds. Okay, so now we then have distance traveled by motorbike at t equals to 15 seconds. So, okay, I can use this. Yes, that will be When it is 15, t is now 15, that will be equals to 80 plus 20 into 15 minus 8. And then this will be 80 plus 20 times 7. This will be 80 plus 140. Of course, this will be 220 meters. Then also, let's consider the distance traveled, okay, by the car. Distance traveled by the car at t equals to 15 seconds. I'm not going to use that, so it's going to be, because when it is 15 seconds, that means that the initial velocity will be, the initial velocity of the car will be equals to 0. So this time we're going to have, yes, when it is 15 to be 1/2 of acceleration. The acceleration is 4/3, then multiply by 15 square, because the acceleration is given to be 1/3. So that will be 4/3. Okay, so this will be 1/2. Okay, this is going to be 2/3 multiplied by 15 times 15. This is 5. 5 times 2, 10. So this is going to be 150 meters. So the greatest distance, the greatest distance, the greatest distance that the motorbike is in front of the car. So if it is in front of the car, so we now find the difference. This time it is not side by side. When they are side by side, it has to be addition. Yeah, we add the two distance together. So the greatest distance, let's say the greatest distance is change in s. That will be the distance traveled by the motor car at 15 meters, 15 seconds, and that of the car at 15 seconds, and that will be 220 meters minus 150 meters. So this will be 70 meters. So this is the greatest distance traveled. Okay, traveled. Distance that the motorbike is in front of the car. Yeah, it will be different. Okay, so now, so we've been able to, so for A, the time we are asked to calculate, we're asked to calculate after what time will the motorbike and the car again be side by side. So, and that is 2.75 seconds. Then the greatest distance, okay, the greatest distance is now 70 meters. Okay, so now let's sketch. Now in the question, we can see here that it said draw the VT graphs for each vehicle using the same axis. Okay, so we have TV graph. Okay, so we know that for motorbike, the time we calculated the time to be, and what was the time we calculated again? That's 8. And then we calculated the velocity to be, okay, the velocity was given to be 20. Okay, so which means from the origin, from 0, 0 to 8 seconds and 20. Then for the car, okay, also from the origin, because for the VT graph, it's going to be a straight line graph because we are using the same axis. Yes, so this one, two, so the time, we calculated the time for this to be 22.5. Then 22.5, then the speed is what? 30. So that means that, okay, from the origin, okay, the graph is a straight line from passing through the origin. This is the origin. Okay, this is V axis, then we have the time axis. Okay, before it now reach the, so for the motorbike, so this is the motorbike, this is for the motorbike. How do I write this? Okay, acceleration of the motorbike will be here. Then the time, 8 seconds. Okay, while the velocity is 20. Okay, because the velocity is measured in The velocity is in meters per second. So time is in seconds. Okay, so now using the same axis, then it gets to 30. 30. So that means this will be 30 when the time is now 2.5 seconds. 2.5 seconds. Okay, 2.5 seconds. Okay, all right. So this is more like a sketch. It is not drawn to scale. All right. Then for the TS graph, because we are asked to sketch. Now this will be in the form of a parabola. Yes, now in form of a parabola. So for the motorbike, for the motorbike, we have for the motorbike is going to be okay. We are using the same 8 and 20. Okay. Then for the car, okay, we got 2.5 and 30. So this one will be sketch. Okay, we can now have for the motorbike. Okay, for the motorbike, what is the initial distance? The initial distance for the motorbike is 80. Okay, the initial distance that's 80. So it goes from 80. This is 80. If we multiply this is 140. Let's say this is 140. This is for the motorbike. Okay, so this is 140. This is the ST graph. So it's going to go this way. Yeah, that's the sketch. Okay, then for the car, it will also be a parabola. So we have S. So the initial distance is, what's the initial distance? I think that's one we calculated to be 337.5. Okay, so if this is 337.5, 337.5, 30, no, this is 30, 337.5. Then it goes to, it's going to go this way. I like to know the value here. That is the other one we calculated. That's let me quickly do that. So we have 337.5 plus 30. Then, okay, I think it was 0. Okay. So there'll be a value here. Yeah, I lost the value, but we already did that. I mean, we calculated the value, in the question. All right, so we've come to the end of this session. I'll see you in the next video. Bye-bye.